So, good day, everybody. I was a little bit scared because everybody left the area, so I thought maybe I'm alone here, so thanks for coming. Today I would like to speak about some measurement possibilities for the routine measurement, but also for the crisis, and I would like to show you what kind of new solution we have to cover dose rate and spectrometry in a very easy way. First of all, I would like to introduce myself. I'm Petra Sattler. I'm working since many, many years, as you can see, at Bertin. I am located at Frankfurt, Germany. And I'm responsible for the environmental radiation monitoring systems in Bertin. Oh. So as you can see, I'm fighting a little bit with the technique, so hopefully our probes will run properly. So first, only a few words if you don't know Bertin. We are involved in radiation monitors since many years. We have, in fact, 4 sectors. We have defense, the nuclear sector, where I'm working in. We have the space and big science, and we have the life science and health devices. Here, when we go deeper in the nuclear part, you can see that we have a big one for environmental measurement. It's for radon. For environmental measurement for nationwide records, we have radiation portal monitors, and we have health physical devices like handhelds and so on. And for sure, we have service, calibration, everything also in our factory that you can get everything from one hand. We are selling since many years these kinds of devices worldwide. That means these probes has to be made to work also in harsh environmental. We are always working on our devices to make them, let me say, more modern, to adjust them on the needs of the customers today. We have big customers worldwide. One of these, for example, EDF has a nice booth here in this hall. And the instruments are developed and produced in France and Germany. What are the general requirements of such kind of networks? I think it started especially after Chernobyl. This was the first crisis we had, let me say, in Europe, and then it was clear that we need monitoring system to detect online the gamma dose rate and all the other things like the beta or alpha devices. The most important thing is to know what is the cause of passing a threshold. And this information is needed to that the first responder can act in the right way. And also, we need to know if the increase of this dose rate is coming from artificial or from not natural radioactive particles. The good point is that the main increase of dose rate is coming from natural radionuclides, something like radon washout. This is a good point. That means for sure we have to detect artificial radionuclides, but the main increase is coming from natural one. We need this information to protect the population. And for this, to make it easy for us, it's a direct measurement very important to know what kind of inhalation, what kind of ingestion, or what is the exposure or the contamination, and how we have to act in the right way. Important for such monitoring systems, for such networks, is that you measure 24/7. Today, the recommended measurement cycle is 10 minutes. That means this devices has to be able to send every 10 minutes data online in real time to the supervision software. And very good is a combination of a dose rate and spectrometry. That means dose rate is for sure good to know, but the reason why you have an increase is coming with, or you can get it with the spectrometry devices. So today we say 10 to 20% of combination behavior. That means 90 to 80% of dose rate and 10 to 20% of spectrometry devices. Very good to know if the increase of the dose rate is coming from natural one. Therefore, you can add also rain sensors, you can add meteorological devices. And the energy supply is one key point, that you do not need very high infrastructure for the measurement devices. The best of such a measurement device is that you can use it totally autonomous, and you see later that our new device works totally autonomous. For sure, alarming, remote diagnostic, these are all points which such kind of devices has to fulfill. Here only a short overview. If you have a nationwide network or ring network, it's very important that all kind of devices can send this information to one supervision software. And it doesn't matter if you get the information via cable or wireless. It's important that your supervision software can handle all this information. And our supervision software, you can see it at our booth. We call it Data Expert 10. We have different requirements for networks. For sure, the easiest one is a fixed installation. You use it mainly countrywide. The second one is a fixed installation around, for example, an MPP. You very often see some instruments on a fence or on a pole around the MPP. And the third one is the one, it has to be mobile, and this is in case of a crisis situation. That means if an emergency case appears, it is very important that you can easily, let me say, densify your network. Here, for example, you see a measurement device for the nationwide network. This is a Sinti tracer. You have the GSM data transmission, and only with this small 10-watt peak solar panel, it works totally autonomous. You need no power supply, no external power supply. It works totally autonomous. Oh, sorry. You have more or less the same situation when we talk about a ring network. Even here, you can use such kind of device, totally autonomous, but for sure you can also put some external power supply on it, and it's very easy to install it on a fence or on a pole. And last but not least, the situation hopefully never happens, that in case of a crisis, in case of an emergency, it's very important that such kind of devices are mobile and very easy and fast to install, even to protect your first responder. So what was the idea of our Sinti tracer? The idea was to combine the best of a dose rate probe with the best of a spectrometry probe. For sure, dose rate sensitivity, when we talk about a Geiger-Müller device, is not as high as we talk about a scintillator, a NRI, lanthanum bromide, or whatever. Power consumption, it's a very important point when you think about infrastructure. The GM tubes, for sure, do not need such kind of high power as a real spectrometric probe. Clear, energy spectrum or nuclide analysis can only be done with a crystal. And it was also an idea to make a very compact and lightweight device that we can use it fixed and mobile or in combination both. And at the end of the day, a very important question for all the customer, for all the user, is the price. So also the idea was to have it more or less between a complete GM tube device and a spectrometric device. So the reason why how the idea was, okay, clear what we will have at the end, but how can we go to the result? And the reason was Since many years, a lot of people are working or improved SIPM detectors. They developed, let me say, a new generation of such kind of devices. And the idea was to combine a small NRI detector with such an SIPM detector. Because the advantages are low voltage operation, high robustness, compact design, and this is also very important, not sensitive to magnetic fields. So we are very, very safe when these probes are used in magnetic fields. And for sure, the long-term stability of such kind of wine, you will use it 10, 50, maybe 20 years, was also a big advantage for us. But, and a colleague from me tells me always, there is no woman without a but. So I say also but. For sure, the difficulty at this point was, how can we make the energy such kind stable that we can use it from minus 40 to, for example, plus 60. This was the biggest challenge. Because without a stable spectrum, you cannot identify radionuclides. It's energy is moving like this. You cannot identify it. Long-time stability, I said you will use it 10, 50, 20 years. This was very important. And the low power consumption. And as I said before, the low-cost budget. This was very important for us. And at the end of the day, the Synthetracer XL2 was born. Because we achieved very high sensitivity in the low dose rate range. We can provide a spectra which can give information about the radionuclide which is responsible for the increase. It is compliant to the Gamma Tracer XL2. For all of you who don't know the Gamma Tracer XL2, it's a dose rate device which are using it since 10, 20, 30 years and which is hermetically sealed. And the built-in rechargeable battery should work or works for more than 2 weeks. The key advantage here is we combine all the, let me say, advantages of a gamma tracer and a spectrotracer. That means we provide spectroscopic data, we improved the sensitivity, and at the end we have a low-cost probe which is available. Here you can see the low power is really low. It's only 0.2 watt, which is very low for such kind of device, and this is why it runs with the standard battery more than 10 days. It is totally autonomous, 24/7, and only a 10 watt peak solar panel, which you see here, is used. We can do nuclide identification for the high dose rate range. We're using still a GM tube. It runs up to 1 sievert per hour as standard, but can be extended up to 10 sievert. It's compact and robust, as you can see here. Data transmission can be also emergency-proof. In this case, we are using satellite. It can be also combined with GSM. And for sure, it's more and more important, we're using a secured and encrypted data transmission. In this case here, you see an external meteo station for 6 parameters, also powered by the device, and the data will be sent together with the dose rate and the spectra to the supervision software to get more information about the wind speed, wind direction, and so on. Here, a short overview. The high sensitivity for sure is given from the 1-inch NRI in combination with the SIPM detector. We have low detection limits. We can determine the nuclides. We have a very high measurement range for the NRI, up to 500 microsievert per hour. And as I said before, we have, in combination with a GM tube, we can go up to 1 sievert and 10 sievert. And here, the very wide temperature range. Here only a few words about the station architecture. It looks really like that. We see the antenna on the top. It can be a GSM, a Bluetooth, or a satellite antenna, and also GPS is integrated. This is very helpful for mobile devices that you do not have to know where your system is installed. You can only use the GPS, and it's automatically installed on the Data Expert map. Every important, let me say, parts like the data loggers, the NRI, the GM tube, the batteries are installed in the hermetically sealed housing. So that means it's IP68. It's really, really, let me say, safe when you talk about wind, sand, but also about water. And in combination, I said it several times, with a 10-watt peak, it runs really autonomous 24/7. Okay, here the station includes also some, let me say, quality sensors. There is a sensor in for temperature, for humidity, for movement. So you can see if the probe is still on this place where it was installed, and the enclosure is hermetically sealed, and we have, let me say, industrial long-life battery inside, the rechargeable one, which should run more than 10 years. Here's some measurement results, but at the end of the day, every device have to measure properly. The other things are nice to have, but the measurement should be reliable. Here you can see the comparison about temperature behavior. We tested it from -40 to +60 degrees, and you can see the dose rate is very, very stable. Here, a comparison from an NRI detector, the 1-inch, which we are using, and compared to a low dose rate 2 GM tube. And it's approximately 80 times higher than the sensitivity than with a GM tube. Here, it's the installation since a long time on our roof in Frankfurt. We have very high temperature. You can see also sometimes in Frankfurt it's more than 40 degrees or close to 40 degrees. And we have a drop down in temperature, and this means we have, after this high temperature, a heavy rain. And you can see the comparison with the drop down and the rain, the dose rate increases. And here, with the spectrometry, we could be sure that it is coming from rain and no artificial radionuclides. Here, a small spectra. You see easily the peak of americium, the peak of cesium, and the 2 peaks of cobalt. Though this is a real spectra given from the new device with, you see, small source in 1 minute measurement time. Linearity, very important when we're talking about norms. There are a lot of requirements when we talk about, let me say, such kind of devices. And you see with even 1 microsievert per hour to 10 sievert, we have ±10%. And the same situation when we talk about energy response. Energy response is also very important when we would like to have a measurement device according to the norms. You see here we made a test from 50 kV to 3 MeV, and the deviation is only ±20%, which is very good for such kind of devices. The summary of that, what I said before, with such kind of device, we combine a lot of advantages. We have the high sensitivity in combination with a low power consumption. And we are able to use such kind of device from -40 to +60 degrees. That means we can use it worldwide. The spectra can be analyzed post-treatment. It's very robust enclosure. That means you can use it in really, really harsh environment. It's completely autonomous with the 10-watt peak solar panel. And we can offer the communication redundancy, GSM and satellite, when we talk of a case of an emergency, because as you know, sometimes GSM has some problems in case of emergency. Maybe the public net fails, but satellite is still working. And last but not least, we have the data encryption that we also can guarantee some security. So that means I'm at the end. Thank you for don't leaving me alone here. Thank you for staying. If you want, here are my contact data, but you can also meet us in Hall 6, where we are, at H081. And if you would like to speak with me, I'm on the booth during this time period. If not, I have a lot of very kind colleagues at the booth. They know it also very well, so you can also ask them. And at the end, thank you very much for your attention, your time, and for making a lot of photos. So thank you very much for that. And the colleagues told me if you have some question, we should go to the small room, and then you can ask some question. We should leave here to save a little bit time. Thank you very much.